So let me start this video. This question has been coming up a lot in my mind lately and in the minds of others. And I want to tell you that before we get into this video, and I promise it will be over 20 minutes long, that I have flip-flopped on this particular point. I haven't flipped and flopped. I'm considering flipping. Let's put it that way. So I like to do these videos in story form. So let me tell you the story of how I arrived at this thought. In 2013, I thought that, so first of all, let me go all the way back. I learned how to code in BASIC when I was 14, and it was relatively basic, right? It was easy. I didn't know there were other languages. So that was the one I just learned. These days, if you're starting out how to code, your first experience with code, if you're not, actively seeking a specific opportunity, is if you're in school in America, it's most likely going to be writing either web pages, HTML, CSS, and JavaScript, or Java for AP Computer Science, or if you're lucky, you'll get one of these new teachers that's going to teach you Python. But if you go to college and they're going to teach you, so CS 50, which is the Harvard college course, for a long time, they started teaching Scratch in college. So you could get a sense of it. And then they would jump right into C. No kidding. And you would learn C next. And then you would learn, and now they have Python in there somewhere. MIT for years taught Lisp only. And this is one of these languages that's absolutely useless outside of the academic space. Haskell was invented as a functional language to teach functional programming. So all of these different kinds of languages, some of which you may have heard of, some of which aren't, many of which are way harder than other languages, people have different opinions about what language you should learn first. And it's not so much in this video, it's not so much about what language you should learn first as much as how hard the language should be. And what are the consequences of learning a language that's too easy and or hard, either way. And so I want to talk about this because people get very tribal. Yes, this is true. But this video is not about that. This video is about how hard should your first language be. And the prevailing opinion right now, I sense, not in academia, by the way, but the prevailing opinion out in the world right now is that Python is the easiest, best first language because it's just so easy. You don't have to mess with the brackets and all this stuff. And I don't want to rip specifically on Python in this video. But we'll deal. C++ is another question, but we're gonna let's. I don't want to tangent into a language comparison conversation in this video. I just want to talk about whether you should learn a hard or an easy language and what that even means. Okay, so first of all, let's talk about what. So I sort of set the stage for everybody thinks you should learn something different as your first language, but underneath all of that is really what they're trying to say to you is they have different priorities for you based on different requirements. And those requirements are based on different things. So one of them is to make you a good programmer, right? Another one is to get you empowered as fast as possible. Another one is to keep you coding so you'll do it more. There are a lot of decisions that are being made. And then there's we talked about this with earlier with about, like what's going to get you a job. Right. So those are questions that are more related to, well, what specific language should I learn? So again, we're going to stay out of that space and we're going to stay into easy and hard. And let's talk about what easy is. So generally speaking, when someone says it's an easy language to learn, what they usually mean is that you're up and running with the language a lot more quickly and there's a lot less specific syntax to learn about the language. There's fewer gotchas and all that. And they almost always equate, when people are talking about this, they almost always equate easy language with Python first. Hands down. Python, Lua, and to some extent JavaScript, modern JavaScript, those will be placed into the easy language category for learning coding or programming. And we're not talking about HTML or CSS, which technically are languages. They're just not, are not commonly defined as programming languages for reasons we'll talk about someplace else. So they're basically, when people say it's an easy language, what they usually mean is it's a higher level language. So this is the thing you need to understand about hard and easy languages and languages in general. When someone says that they're programming in the higher level language, that means that it's not better. It means it's closer to you as a human. So the purposes of languages in general are to take you, the human, and make it so that you can communicate with the CPU down here. And there are many different languages that meet different levels in the closeness to the metal, right? How close you are to the metal generally defines how easy or hard the language is, with the hardest, hands down, being assembly. That means short of writing literally ones and zeros, you are writing very, very low-level cryptic stuff that in your code that you write actually has intimate knowledge of the specific memory registers on the hardware that you're writing the code for. So there's no levels of abstraction. That's the closest to the metal. That is hands down the hardest to do, or the lowest. Now, if you wanted to pick a language based on what one's going to help you understand your specific processor more than any other language, assembly is it. Because if you code assembly, or learn how to code assembly for a specific chip, not just a computer, but any chip, then you learn the intimate details of that hardware and that chip. And if that's your goal, then even though that's a really low-level language, that might be your best first language, even though it's not easy at all. Because your goal is to learn how to code microchip PIC8s, which is, you wouldn't, but ARM chips or something like that. If that's your goal, and that kind of goal doesn't exist usually unless it's a very high level of academia or something. So, and then from that moment, you go all the way up. And I would argue that the languages that are on the highest plane, I would think JavaScript is absolutely the farthest from the metal possible, because JavaScript doesn't even require that you have it installed on your computer, because every single browser has it in it. So it is the highest level language. It's the most accessible. It does the most crazy transformations. So at the higher level here, some of these abstractions are going to mean crazy things like duck typing. It looks like a duck. It quacks like a duck. It must be a duck. And I don't want to get into the specifics on this, but suffice it to say that at the highest level, your language is so trying to help you out as a human being that it tries to guess what you mean as a human. So it's trying to help you so hard. Its intent is so hard on helping you that it's like, oh, didn't you mean this? Okay, you typed the letter 0. You typed 0 as a string, but you really meant the number 0, right? So I'm going to treat it like the number 0. Yeah, there you go. So there's a lot of people are going to come out with this stuff. Scratch too. Scratch is another very higher level one. So the higher the language, the more the goal of the language is to get rid of the thinking for you and let you focus on what matters. That's what they say. The logic and the algorithm and getting something that you want built. And visual languages like Scratch are in that vein. Visual languages like, there's like visual languages like Unreal Engine. So you guys might bag on Scratch, but Unreal Engine is Scratch. Game Maker Engine is Scratch. It's got a lot of graphics that people can do. You know what I'm saying? So you're starting to see the chat come alive right now, because at the highest level, when a language tries to be very magical and guess what you mean, you get a lot of problems, because sometimes it'll interpret something you said completely wrong from what you really intended it to mean. And there are so many examples of this. I don't have time to go through them in my remaining 15 minutes, but some of the ones are already in the chat, and you can go search out some of the amazing reasons that people really, really hate JavaScript because of this, because it's so loose in its typing. Now, when we say loose, what we mean is that it does a lot of guessing for you. You don't have to say what it is you're making. You just say, I want these letters together and I want it to do this. Well, if you treat those letters as a number, it does something else and tries to do the right thing for you. That is called loose typing. And we don't want to do a video on typing right now. But this is something that is generally consistent with how low and how high the language is how strictly typed the language is, generally speaking. And what that means is that as you get down farther, like when you're down here, you have to specifically say what memory register by number you want to deal with. That is the strictest of typing, because you have to say exactly what you want to happen to this piece of hardware at that specific section of silicon that exists in that moment, or, whatever. And, yeah. So what you have here is, and you go up, and as you go up, you have C, And so C is a strictly typed language. It's also compiled. The languages that are, lower tend to be compiled. They're not always compiled, but they tend to be. That means you have to do an extra step to take it from code into something that will run on your computer. It's called compilation. You don't have to do it with Python or JavaScript. Just open your browser and start typing, and it does it. Okay, so those languages are interpreted. So easy languages are largely interpreted, and that means you have your own sort of C3PO there to take what you're saying, translate it into bocce, and talk to the moisture evaporators or whatever. You know what I mean? So that's the interpreter is doing the talk for you to the machine or to R2, which can't speak English, right? So that's what's happening, and so it's a very high level. But as you get into the middle and the lower, so this is what we mean by easy and hard. And so easy languages, generally speaking, are very, very loosely typed. That means if you use something like a particular type, it'll assume that that's the type you want. It doesn't force you to say that's what type it is. That's a loosely typed language. They're generally interpreted, which means they're not compiled, and not always, but and that's the main distinctions. And sometimes the syntax is easier to understand. So in the case of Python, people think that the fact that there's no curly brackets in how you write the language makes it an easier language. I think it's actually a huge flaw, because all of the other languages in the chain, pretty much every single one, there's very few isolated cases where it's not true, use C-style syntax, which uses curly brackets. Okay, so as you see these different levels, you have to decide what language you're going to learn and where you want to jump in. And so now that we understand hard and easy, the last part of this video is going to be helping you decide which type of language, not which specific language, but whether you want to learn a hard or an easy language for your first language. And we have a lot of really great people in the chat who have done a lot of this, people that participated in Lead Code or done their own coding or taught themselves or been through CS degrees. All of them have different opinions on this. But as the closer you get to academia and computer science, the more that they will tell you you want a strictly typed language. And this is why Java is on the AP Computer Science test. It might be an abysmally bad, bloated language, but when you learn Java, and I mean, I hate coding Java, but when you learn Java, it is so verbose in how much you have to say about what you're doing. You have to declare that it's virtually impossible for you to not know what's happening. If you lose track of what's happening with your language, it's because there's too much writing, because it's very verbose. And a lot of people say language gets you the job. We're not talking about that. That's a different topic. So if you're trying to learn an easy or a hard language, my question is, which is the easiest? Should you learn a hard language or an easy language first? And let me go back to my story. So in 2013, when I started, I thought Python was everything. Everybody should learn Python because it was the easiest for people to learn. They could get right up to speed. They could learn about if statements and logic and variables very quickly, and they could be relatively productive from the command line really quickly. And it's all true. And that's all the reason that people really love Python now. And then I saw a problem. I saw something happen. I saw people that I had taught Python not go into learning any other languages because they didn't want to learn another language because it wasn't Python. And so they became these really flaming language bigots who didn't want to learn JavaScript. They didn't want to learn Go or C or anything because they had learned Python, and by God, that was all they ever needed. And I believe that was largely because the syntax was so different from all the other languages. They weren't inclined to pick it up. Was it because the language was too easy and therefore it fulfilled all of their needs and they didn't have any other needs? At least they didn't think they did, until they got burned by them, right? So that was my experience. And somewhere in the middle there, I realized that people were losing interest in Python because they couldn't do things in the web that were graphic. They couldn't make games with Phaser. They couldn't do anything. So I moved to JavaScript also because JavaScript is a better language for teaching really, really important computer science concepts, such as first-class functions, anonymous function assignment, things like that can't be taught in Python because they don't exist. Switch statements. Python is missing a lot of really important things that I believe are really important to learn and just in general about programming. And JavaScript has those things, and it's still interpreted in Lucy. So I moved to JavaScript for many years and actually recently concluded with that. But now what I'm asking myself is that a disservice? If I'm going to try to teach it, you got to understand, I was teaching people between 9 and 18 or so. and or mentoring people at that age. If I try to give a 10-year-old a C class, they don't care. Now there are people who are obsessed with coding for coding's sake, Raritan. I'm just kidding. People who like to code just because they like the act of coding, and they tend to be attracted to the serious languages like Go or BrainF even, or a number of these other languages that are very low level, because they like the act of coding and they like all of that. Now they might not like JavaScript, but these are also the kind of people who really, really love Rust. And the Rust community, for better or worse, and I actually think for better, is very into having people learn how to code safely first. Now, the bad part about Rust is that Rust puts the training wheels on you in a way that keeps you from making really serious mistakes that you would make in C, and that's great. It's very, very safe language. It's very, very hard syntax to learn. I would never, force a beginner to learn a pointer for Hello World. But the point being is that the case people make for Rust is, you're going to write, nice safe code no matter what. People can make the case for Python and say, hey, you've got all this data science stuff in there already. It just works. But I think the more the training wheels are there in an easy language, the less you learn about the language. So, and I believe that most of the time when you're learning, if you have time, and you're trying to pick out whether you should learn an easy or a hard language, I think you should learn a hard language first. And so for the beginner boost, I have 8 minutes left to say this. This is the reason that we will be learning Shell, which is the easiest language to learn of all. It's very weird. It's a very, very weird language, but you're already using it. Every time you enter a command on the command line, you're writing code. So you might as well learn it. So this is very unorthodox. The first language we will be learning on the beginner boost is Shell. And that is the language you use every day to interact with your computer from the command line. That is a language. That's what says bash, but we're going to do Shell. So that's the first language we're going to learn. And then the second language we're going to learn is C. And people are going to yell at me for doing this, but C gives you the most direct knowledge of how your computer works from any other language. By learning C, you probably never code any C again in your life professionally, maybe so, but learning C for understanding is really key. And we're not going to go really deeply into it, but we're going to learn, to learn C, you have to understand how your computer works. What memory is, what's a pointer, what is a function? When I write a function, what does it turn into when it gets loaded up into my computer? Where does it go in memory? How come all these people can hack computers just by overflowing buffers? You'll understand all of that because it's a low level. We're not going to learn any data. No, we're not learning reverse linked lists or any of that. We're learning C for understanding. We're not learning it to master data structures and algorithms. That's not why we're learning it. If you want to do that, that's fine. But we're going to learn just enough C to understand how your computer works. Okay. Got it. See you in 5 years. Yeah. We're not learning all of C though. That's the thing you're mistaking. So we're learning Shell in order to become productive. So we're learning the minimum, and then we're learning the minimum amount of C to understand how your computer works. And then that's what a boost is it's just enough to get you started. And then if you want to go down that road, you can. And then we're going to learn Go, and Go is a higher level language above C, that's kind of in the same space as Python. And after we learn Go, we'll learn Python. So, and because Python, I want that to be last because I don't want people to get confused by how different the syntax is. But that's good because Shell is a different syntax too. So, so that's what I think you should do if you want to understand your computers. You want to see. This particular approach is not an approach I can take with a group of 9 to 19-year-olds. So the decision about whether you should learn a hard or easy language is not, there's no answer to this. The answer to this is for you. It's like, what is your goals in learning the language? Are your goals become productive or get a job? Then you want to, or to be the most efficient at doing something, then you're making a different selection. If your goals are to learn and understand how your computer works and how programming works, or ultimately how data structures and algorithms work, or all of these things, then you're going to have a different set of priorities about what language you pick. And you might pick C if you want to learn object-oriented programming. For whatever reason, understanding it, that would be a Java or a C# or a C kind of, C++ kind of thing. Yeah. So the reason that I have stuck with Python and JavaScript for the beginners is because they can immediately see results from what they're doing. So immediately they have, I taught people Python and they wrote their own automated dungeon generators within a year, because they had so much power at their fingertips that they were able to do that and never care about anything else. But it was in my pro group that was like, I'm going to teach myself C, or Gabe, I'm going to teach myself assembly. And they took it on themselves to learn assembly. Now, had I started by teaching them assembly, I don't know that they would have went that route. They might have gotten too disenfranchised by it. But it's kind of like, should you learn Arch versus Gentoo, or versus, doing an LFS system and building it, or, just using Debian and Ubuntu, because it depends on what you want out of it. If you want to be learning while you're doing your Linux distro, tinkering, if you just want something that works, but Papa wants to be done with it. If you just want to write a simple algorithm that does your math for you, do it in Shell or Python. And by the way, there's no easier calculator than just BC. It's way better than Python. So, those are the reasons. So should you learn a hard language? My personal conclusion is that when I do the beginner boost, there's so many things that I've changed about the beginner boost from what I did at SkillStack that are now fundamentally based on giving you a really, really, really solid foundation. So I'm assuming that you're not under stress to get a job right away, or that I don't have to motivate you to stay motivated in learning this stuff. I'm putting that stuff aside. Up till this last 2 weeks, everything I did at SkillStack was to sort of Hansel and Gretel you into wanting to code by enticing you with games and Minecraft servers and all this stuff to create this artificial interest in something that you might not be interested in something else that you may or may not be interested in, and then hope that someday you might actually be interested in C and understand how your computer works. And I'm not doing it anymore. So the beginner boost is starting with the assumption, number one assumption. I want to understand my computer and how it works from the ground up, and I want to become efficient, and I want to build everything on top of that. And then if you want to do the games and everything, you can take that and you can layer those things on top of that. You're not going to learn how to make a JavaScript game and then come back someday and go, I want to make this multiplayer. I need to make a server. And then I say, well, you should need to do this and this and this and this for server side stuff. And they're like, really? That's hard. Right? No more of that. We're starting with, this is how your computer works. This is how your kernel works. This is how memory works. This is how permissions work. This is what network addressing does. And then we'll build layers on top of that. And then we'll move up and we'll add on. And this is consistent with how AP Computer Science approach works. AP Computer Science is very serious from the get-go, and that puts people off a lot, because Java is, the other thing that puts people off is that AP Computer Science assumes the only thing that you should learn as a beginner is object-oriented programming, which is so wrong today. And you should just run screaming from AP Computer Science unless you supplement it with some other approach. And by learning from the ground up with C, we will understand that the lowest level of a computer is not object-oriented. It's imperative. It's functional, and then they layer on things on top of that, and all the layers that come on top of that are all there to help you understand and make sense of what your computer is doing in different ways. And every one of those additional models that comes on top of it is all designed based on an assumption about how humans see the world. And that's why you get the difference between object-oriented programming and functional and imperative programming and all of that. And you get vast divergence in what is best. So over here you have Lisp and Haskell, over here you have C# and Java and C++. And those are vastly different ideas about how you should look at the world in order to make your computer understand what you want to do. But if you go all the way down to the base of your computer is assembly and C, and understanding how those things work and adding the layers on top will let you choose which path you want for going forward. So object-oriented is very, very high level. Yes. And that's the end for this video. I'm right on time, 23 minutes.